Hello everyone, my name is Mihir Pawar. I'm graduated from Pune University with a bachelor's degree in IT engineering, where I achieved first class with distinction. During my time there, I worked on an exciting project titled Disease Detection in Cotton Leaf, which was based on machine learning algorithms. So this project not only owned my technical skills but also sparked my interest in intersection of agriculture and technology. Currently, I am furthering my education by pursuing PG diploma in advanced computing at CDAC Mumbai. So this program has been instrumental in deepening my understanding in various models like object-oriented programming, database technologies, and also web programming technology. And also, in addition to my academic pursuits, I completed a virtual internship, which was focusing on AWS Cloud Foundations and Architectures. So, which this provided me with a solid grounding in cloud computing principles and practices. So, outside of academics, I enjoy sketching. It's a great way for me to express creativity. And another hobby of mine is exploring Google Earth. Yes, I find it fascinating to virtually travel and learn about different places around the world. And today, as a part of our placement activity, I'm going to explain the topic of normalization in DBMS. So let's quickly talk about normalization in database. So what is normalization? Normalization is just like tidying up your room to make things easier to find and keep everything organized. Yes, in database also, we have to make things easier to find and keep everything organized. Just like in object-oriented programming, we encapsulate our code in classes. Why? Why? To keep our data organized. So here in database also, we have to keep everything organized. So in terms of database, normalization is a process of structuring relational database to reduce redundancy and improve data integrity. So what is redundancy? Redundancy is repetition of our data. And what is data integrity? Data integrity is accuracy and consistency of our data. So normalization is a process to reduce redundancy and improve data integrity in our database. So how we can achieve all this? Yes, by using normal forms. So let's go ahead for our first normal form. So here in first normal form ensures that each column in the table contains atomic values. Okay, each column in the table contains atomic values. What do you mean by atomic values? Atomic values means indivisible values, which cannot be divided. So each column in the table contains atomic values, and each column contains value of a single type. So for that, we will take an example. So here you have a list of students and the subject they study, but this is in a disorganized format. How? Mohit has enrolled for subject DSA and as well as Java, and here subject column contains multiple values, which is not allowed in first normal form. So to convert this into first normal form, we ensure that each subject is in a separate row. Like in second table, we can see here. Now each row has one subject. Like Mohit, first row has Mohit with subject DSA, and again Mohit with subject Java. So this makes us easier to manage. So this ensures that our data is atomic and organized. Each cell contains only one piece of information, and each column contains only one single type of data of a single type. So this was about first normal form. Let's quickly go ahead for second normal. Yes. Now second normal form. So it builds on our first normal form. So second normal form ensures that all non-key attributes are fully dependent on the primary key. What are non-key attributes? Non-key attributes are columns that are not part of the primary key. So all non-key attributes are fully dependent on the primary key. So this means that each piece of the data in a row should relate to entire primary key. So let's consider an example. So consider this an order table. Here in this table, customer name is repeated for each order made by the same customer. So to avoid this repetition and to meet second normal form, we split the table into two. So in two tables. So what are these tables? We can see after using second normal form, here order, we have split the table into order, customer and order detail. Now the customer information is stored only once in the customer table. So this reduces the redundancy and makes updates easier. So every non-key attribute is fully dependent on the primary key. Okay, here every non-key attribute is fully dependent on the entire primary key of its table. So we by this we ensure that there is data consistency. So this was about second normal form. Let's see what is third normal form. So what is third normal form? So third normal form requires that all the columns are not only dependent on the primary key, but also independent of each other. This means that there should be no transitive dependencies. What is transitive dependency? A situation where non-key columns depend on the other non-key columns. So there should be no transitive dependency. So let's look to an employee table here. So here department name depends on department ID. So which in turn depends on the primary ID, that is primary key. So to achieve third normal form, we separate department information into its own table. So here after using third normal form, we use department information into its own table, that is department table. So by this way, each piece of information is stored only once. Now, department name is directly linked to department ID in the department table, eliminating any transitive dependency. So this ensures that data is more organized and efficient, and changes in the department name do not require multiple updates. So this was about third normal form. Let's go to our fourth normal form, which is actually called Boyce-Codd Normal Form. Okay, so its short form is BCNF. So what is BCNF? It is stricter version of our third normal form. So it ensures that every functional dependency where X is functionally determined, uh, X functionally determines Y. So here X should be the super key. What is super key? A unique identifier for our row. So for that, let's consider an example. So here we have a course table with professor, course ID, course name. So in this table, a professor can teach multiple courses. Like here, Kiran madam is teaching data structure as well as operating system. So a professor can teach multiple courses, and each course is taught by one professor. So to achieve BCNF, we split up this table into more tables. So BCNF ensures that all the dependencies are on the super key, meaning that every determinant is a candidate key. What is determinant? A column on which some other column is fully functionally dependent. And what is a candidate key? A candidate key is a column that can uniquely identify any database record without referring to any other data. So every determinant is a candidate. So this makes our data structure more robust, reducing anomalies like insertion, deletion, and updation. So it reduces anomalies and ensures that there is a data integrity. So in conclusion, normalization is very crucial for creating efficient and consistent databases. So by applying different normal forms, we reduce redundancy and ensure that there is data integrity. So the more we use normal forms, the more our data is on safer side. So it makes easier to update and manage our databases. So whether it's organizing our students or employee tables or this courses tables. So normalization helps us to keep our data tidy and reliable. So thank you for listening. This was about today's topic. Let's meet in the next video.